Hello students, in this video we will be taking up the topic of linear equations in two variables. In this video we will be covering the basic concepts related to the topic of linear equations in two variables. We will start our lecture by defining a linear equation in two variables. You can see the definition on your screen. The definition states that an equation which contains two variables and the degree of each term is 1 is called a linear equation in two variables. So what are the points given here? First, it should have two variables, and second, degree of each term is 1, meaning the degree of each variable should be 1. When I say degree, it means power. The power of each variable should be 1. Let's take an example to get better clarity on this concept. On your screen is a equation 5x plus 3y plus 7 is equal to 0. In the given equation, x and y, the letters are called the variables. 5 and 3 are called the coefficient of the variables, and the third term of the equation, which is 7, is called the constant of the equation. If you observe carefully, the variables x and y have power 1, and hence the given equation is a linear equation in two variables. The general form of a linear equation is ax plus by plus c is equal to 0, where a and b are the coefficient of the variables. If you compare this equation with the above given example, we see a is 5, b is 3 and c is 7. So what are the necessary conditions for this equation to be a linear equation in two variables? First, a and b should be non-zero. That means it should take any value other than 0. A and b cannot be 0. And the second condition, the degree of variables or the power of variable should be 1. In the given equation we have two variables x and y. Their power should be 1. It cannot be a square term or a cube term. Let's take up some general conditions. The first general condition is given on your screen, where the two coefficients of the variables are taken as 0. Such an equation will not be a linear equation, because a linear equation requires the coefficients of variable to be non-zero. In the next general condition, we take the constant term c as 0. This reduces the general equation to the form ax plus by is equal to 0. This equation in reduced form is a linear equation in two variables, because it satisfies the two conditions, which are the coefficients of the variable is to be non-zero, and second, the power of the variables should be 1. Let's take up some examples. First example, 5x squared plus 3y plus 7 is equal to 0. Let's discuss whether this given equation is a linear equation or not. No, it's not an equation. Why? Because the power of the x term is 2. For equation to be a linear equation, the power of x term or the power of the variables should be 1. Second term, 5x plus 0y plus c is equal to 0. No, this equation is not a linear equation, because the coefficient of the second variable y is 0. As we had discussed earlier, for an equation to be a linear equation, the coefficient of the variables should be non-zero. Third example, 4xy minus 5y minus 8 is equal to 0. No, this equation is not a linear equation because the first term has two variables, x, y. If you remember, the general form of a linear equation is ax plus by plus c is equal to 0. If you observe the given example carefully, the first term has two variables x, y, and hence it cannot be a linear equation in two variables. Let's take up some examples to discuss the application of linear equation in two variables. On your screen we have two equations. These two equations are of the form of linear equations. Here if you observe carefully, the coefficients of y are of opposite signs. We can eliminate the y term by adding these two equations. This will reduce the two equations to the form of a single variable, and by solving that equation we can get the value of the variable. We add these two equations. When we add these two equations, the y term gets cancelled and the equation reduces to a single variable form, which is 7x is equal to 21. Solving this, we get the value of x as 3. We can substitute this value of 3 in any of the given equations, and solving it we can get the value of y. I have substituted the value of x in equation 1. Solving the equation 1 after substituting the value of x, I get the value of y as minus 2. Let's take up another example. We have two equations here. 3a plus 5b is equal to 26. A plus 5b is equal to 22. Here if you observe carefully, the coefficients of the second variable is same, both numerically as well as with respect to the sign. In this example, the coefficient of b in first equation is plus 5 and the coefficient of b in the second equation is plus 5. In both the cases, the value of the coefficient is the same. In such cases, we subtract the two equations. When you subtract the two equations, the second term gets cancelled and the equations reduce to a single variable form, which is 2a is equal to 4. Solving this, we get the value of the first variable a as 2. Now you can substitute the value of a in any of the given equations to get the value of b. Substituting the value of a in the first equation, we get the equation reduces to the form 5b is equal to 20. Solving it, we get the value of b as 4. Let's take a third example. In this example, if you observe carefully, the coefficients of the variables are interchanged, meaning in the first equation, the coefficient of x is 5 while the coefficient of y is 2. However, in the next equation, the coefficient of x is 2 while the coefficient of y is 5. To solve such equations, we first add the two equations. We write down the equations as given on the screen and add them. When we add the two equations, we get a third equation which is of the form 7x plus 7y is equal to 182. We reduce it and it is reduced to the form x plus y is equal to 26. Now we subtract the given two equations. When we subtract the given two equations, it reduces to the form 3x minus 3y is equal to 42, which can be simplified to the form x minus y is equal to 14. The simplified form is obtained by dividing the equation by 3. In the above equation, we get the equation 3 by dividing the equation by 7. Now, when you observe equation 3 and 4, it is similar to the conditions mentioned in the first example, where the coefficient of the second variable is of opposite signs. We can simplify these two equations as we had discussed in the first example. Add these two equations and get the value of x as 20. Substituting the value of x in any of the equations, we get the value of y, which comes out to be 6. I hope you all found this video to be useful. Thank you.